Welcome back, everybody. We are back from spring break and a holiday. Today is week 11, 10. So we're gonna cover this brand new topic called arrays and a couple of little algorithms on it. I am aware that some folks are ahead of the class and have been kind of doing the future reading. So I saw some folks used arrays and array lists in previous programming projects. That's fine. That's totally fine. It's okay to use future topics in the programming projects. But I'm pretty much saying that if you're already comfortable with arrays and array lists, you're probably not gonna get a lot out of today. But yeah, for the folks who haven't heard about these, you're probably gonna get a lot from today. All right. Okay. So yeah, let's cover this brand new topic. I recommended a couple of readings from the MOOC, the primary resource over here. Right over here. I did recommend it out of order a tiny bit though. So here we're first going to start off with arrays, and this is 3.3 over here in this section. Let me just pull it up over here. It's kind of out of order. I'll kind of explain why later. But 3.3 is right over here, and then next is array lists. We're probably going to cover this next week, but for some reason this is 3.2. I feel like it should be reversed though. The reason why I feel like these two should be reversed is because arrays are simpler, and array lists are built using arrays. So yeah, that's kind of why I'm doing things a little bit out of order from my reading, because arrays are easier and then array lists are a little more. All right. Okay, so let's talk about arrays then. We're gonna see a data structure finally. We've actually already seen data structures before, especially with strings. Strings are like it's like a data structure, like it's like a data structure of characters. So we've kind of seen this before. Like if you were to have this string called ABC, it's pretty much the same as representing a character array of 3 things. So pretty much a string is like a data structure of characters. So yeah, that's pretty much what you'll kind of see today. We're going to be seeing this part, this highlighted thing. That this is called an array. All right, a character array. Okay. So I want to motivate it with this picture over here. Some folks might recognize what this is. This is a Minecraft hotbar. I pulled this screenshot from a Minecraft game. So a hotbar in some games, you can kind of visualize it as like a data structure with elements next to each other. These are empty currently. They're empty, but if they were to be filled up like all the way to the max, you could access them instantly. In the context of like a hotbar, like a Minecraft hotbar or some other game, these elements can be accessed instantly if you just press like some keyboard shortcut, right? Like if you wanted to access this element here, you would press 2. Access this element here, you press 6. All right, so that one of the key takeaways on arrays is they are instant access. All right. Another key takeaway from arrays is something called contiguous memory. This means that the elements are right next to each other in memory. So if you were to like metaphorically, if you were to open up your RAM stick, like your memory stick, arrays would be kind of stored contiguously where the values are next to each other. All right, and I am speaking metaphorically because in memory they're actually virtualized memory, so it's not really physical. Anyways, that's out of the topic. So yeah, this is an array. There's instant access. All right, they are useful for storing items. Sometimes you might want to store like related values next to each other. Right? Like maybe you wanted to store some data in certain elements. Here's a picture of a locker that kind of visualizes that. Sometimes you might want to use arrays to maybe maintain catalogs, like maybe you have a priority list, right? A priority list where the front of the line is more important, and then maybe the back of the line is the least important. So you could maintain lists like this. All right, and speaking about lines, this is a queue right here. It's you can arrays are also useful for representing queues, like where things are kind of lined up where first in is the first out. So this person here is the first person in, so he's going to be the first person out of the line, and then next everyone's going to shift over. So yeah, arrays are good for maintaining these types of things as well. All right, so here let's introduce some syntax and create our first array. So this is going to be quite dense here. There's a lot of text, but I'll break it apart. Okay, so the anatomy of an array declaration. There's multiple ways you can create an array. All right, this is just one way. In the next slide, we'll show like multiple ways on doing it. But here, let's break this apart real quick. I know there's a lot of text here, so let me just break it apart. Okay, so looking at the top over here, this is called a declaration and initialization. Right? This means to create an array and allocate it to some amount of memory. All right, so let's actually type this right away. Let me pull up a VS Code over here. Let's see. For this project, I'm just gonna keep it in one file. I remember in last class we separated into multiple files, but yeah, for today I'm just gonna keep everything in one file. Let me call this. You know, I'm gonna call this hotbar. I'm gonna call it hotbar.java. The reason why I'm calling it hotbar is so I can represent this context here. I'm trying to go off this inventory game where you have like shortcuts to access elements. Right, so that's why I'm calling it hotbar. Okay, so I just created a hotbar. Let me resize my screens here. Hopefully people can read this. Okay, let me set up the void here. Void main, this is the entry point. Okay, cool. So right off the bat, I'm actually going to go ahead and declare a string array. So I'm not going to use a double here. I feel like people are getting tired of numbers. You're probably getting tired of math. Maybe you came back from math class just now. But let's work with strings. So I'm going to declare a string array. The syntax for it is just like allocating a variable. You basically say the type of the data, and then the difference here is we need these things right here. What are they called? The square brackets. All right, so these square brackets says that this is now a string array type. All right, and then next we need the name of it. The name of it doesn't really matter too much, but I'm gonna name it hotbar. Okay. So yeah, this is the type, and then this is the name. Okay, so just to slow down a bit, this is the bare minimal syntax we need, kind of, to create a array. So you could put a semicolon here, and it should compile and run, but it's not gonna do anything. Here, let me test it. I got a CD into examples, and then Java hotbar. Okay, cool. It compiles and it runs. It doesn't do anything though. So let me explain what this is doing. So this left side right here is declaring. All right. So there's actually nothing in it yet. You can think of this as a reference, by the way. A reference is like kind of a pointer to somewhere else. So yeah, this double values is what representing here, but now we need to tell the computer to give it some blocks, right? Like allocate a bunch of memory. If in this case, if we were to allocate like 9 items, then on the right side of the equal sign, so here's the equal sign. On the right side of it, we would put this command here. This new double 10, which is pretty much telling Java to allocate memory for 10 different doubles. All right, but in this case, I'm going to use a string, just because we were probably tired of numbers. So let me go here. Okay, so I'm gonna type this over here. Let's see. So hotbar is now equal to new double. I mean, not double. I'm gonna say string because we're using strings. And then the length of it, how much memory to give it. So I'm gonna give it 9. I'm giving it 9 items because I'm trying to represent the Minecraft hotbar, which is here. There's 9 items here, 0 all the way to 8. All right. Okay, so let me make sure this runs real quick. Okay, cool. It compiles and runs. Okay, great. And then next up, this is called an accessing. In this case, it's accessing an element and then initializing it to some value. Right? Because currently, if I were to access certain things in this hotbar here, let's find out what happens. So one way we can access things is by using this notation here called the square bracket notation. Basically, you would put these square brackets and then the position inside of it, which will access a certain element. So for example, if I were to access like the first element in it, I would put hotbar 0 here. This is saying access the 0th element in the hotbar. So let me go ahead and put this in a print statement just to see what happens. Let me go print line actually. Print line first element is, actually let me use a print format. Print format string. Okay, I'm using a print format so I could put the string in here. Okay, let me test this real quick to see what's happening. Okay, people kind of seeing what's happening here. So the first element here is null, and the second element. Let me try the second element just to see what's going on. Second element is represented by the 1, by the way, because we start counting from 0. Okay, so we go ahead and run this, and yeah, both of them are null. All right, so the reason why this is happening is because when we allocated memory for the string, the default initialization is to put them all as null. So these are doubles, by the way. If you were to work with numbers like integers and doubles, they're probably going to default to 0. But for strings, it looks like it's defaulting to something called a null. This null pretty much means it doesn't exist, or it's uninitialized. So if you were to initialize certain things, one way you could do it is by accessing the element and then manually initializing it to some value. So if I were to do that to the first element here, I could say hotbar 0 is equal to something. Right? This is saying grab the first element and reinitialize it to something else. Right, so here I'm gonna put let's see, what do people usually store in their first over here? Right, I'm pretty much saying in some game, in any game, it could be Minecraft or whatever. What do you store in this first element? Right, some people probably store like a sword or something, so they would say this is equal to a sword, and then the and let me get the second element equal to something. Maybe some people put a pickaxe here for some reason, so let me put a pickaxe here. All right, okay, let me go ahead and save this real quick. So let me save this and run it. So compile and run. Okay, cool. Yeah, so now the the first two elements are initialized. All right. Cool. So hopefully that kind of makes sense. This was really just an intro on the anatomy of arrays. All right, this is just one way. Okay, any questions about this? Let me pull the chat real quick. Pull the chat log. Okay, people didn't. Okay, nice. All right. So there are tons of ways we can work with arrays in Java. Let's see. Yeah, tons of ways. I only put like 4 of them here, but if you were to do a bit more reading and read other people's code, you'll see other styles too. In this, I'm using the very first style. This is like a classic style. Where on the left side you declare something, and then on the right side you would kind of initialize something. All right. There's other ways here. You can see this later. Okay, let's move on. You know what? We should probably play around with this a bit more. So with arrays, this is a data structure that complements with loops very well. So you see how I'm kind of printing out the first and second element manually, and if I were to print out the third element, I would have to kind of repeat this code here and then replace this and then run it again. So this does work, but with arrays you typically using loops to go through it. All right, we'll talk about some common array algorithms later, but one common array algorithm, just for a start, is looping a print statement at least. All right, so is there? Can folks maybe try this out? Can folks maybe try and write a loop to do all this? I would recommend pausing the video and trying it out yourself. But yeah, there is a way. Basically, you just have to find a way to loop some numbers. Right? You just got to find a way to loop from 0 all the way to 8. Right? Because 8 is the very last number. So yeah, we can just set up a loop. Right? We can just like we could use a for loop. For loops are good for finite items. You could use a while loop too, but it's going to be a little longer. Okay, so for a for loop, I'm just going to represent a number that starts from 0 and goes all the way to 8. So I is less than 9, right? By saying less than 9, this is going all the way to 8. And then plus I here, which is, well, by the way, plus I is the same thing as saying I is equal to I plus 1. You probably already saw this in the reading. Okay. And yeah, so I is a number, and we can use that number to access all of the elements now. So I'm just going to do the print statement in here. Let's do a system print line, and then let me see. Let me put it in like a. Let me do print f actually. Print f because I want to print out the number. I'm going to print out the number, colon, and then the string associated with it. So basically this is going to look like 0, sword, 1, pickaxe, 2, null, 3, null. That's pretty much what it's going to look like, because a D is the digit or a decimal number, and then S is a string. And then I'm just going to go ahead and substitute I, which is the decimal number, and then now I need the string. The string is the element at the hotbar. All right. Okay, let me go ahead and run this real quick. So Java, and boom. Okay. So there we go. There we have it. We wrote a loop that iterates through the whole hotbar and just prints out what's happening, or what's at the element. All right. Okay. So it's probably a good idea to practice a bit. I would probably recommend pausing the video again and seeing if you can wrap this in a function. I mean, a method. A method was one of the last things that we learned. So I would recommend this as a class exercise to see if you can do it. Actually, I don't think you have enough to do as a class exercise yet. My bad. Because I forgot, I need to back up a bit. So this 9 right here is technically hard-coded, by the way. It's hard-coded because we're assuming that the string array is length 9, which is a correct assumption, but one can consider this a magic number. So you know, there's multiple ways you can generalize this a bit. Well, one way you can generalize it is by using like the dot length variable. So you could say like hotbar dot length here, and this is pretty much this is called a member variable. Now, you don't have to worry about this too much, but I'm pretty much saying that length is a variable that belongs to hotbar. And yeah, so this is just really just saying 9. It's so let me run this real quick. Okay, cool. We get the same behavior. Nice. Okay. Okay, cool. Let me see if they cover this in the reading. Array dot length. Yeah, they cover this stuff. Yeah, highly recommend doing the reading. Okay. Let's see. So yeah, a good idea would probably be to wrap this in a function. I mean, a method. Like, imagine if this didn't exist. Right? Imagine if, imagine if it existed somewhere else. That's what I meant. So I just removed the for loop in preparation for a class exercise. Can folks see if you can try this out? Like, imagine there's a function, method called print array. Print array, and then imagine if you sent it the array here. All right, so the goal here is print array is a method that takes a string array. All right, so it takes a string array and then maybe just iterates through all of it. So yeah, go ahead and try that out. Oh, you know what? Here, let me help folks get set up with this because you're probably a little rusty from spring break. My bad. So a print array. What is the return method? The return value, or a return type? I mean. Okay, well, here it's a void because we're not seeing that this is like being captured into some value, right? If we see it being stored into some value, then this is no longer a void function. Right, but yeah, hopefully people see that this is void, and then the name of it is print array, right? And let me get the body here, the curly braces. Okay, so now the what's it called, the parameters. All right, what's the parameters here? We need to describe a string array somehow. All right, so it's the same as doing a normal variable. Right, like in this case, we're just doing a string array. So you can just say the parameter is a string array, and then you can name this whatever you want. Right, I'm just gonna name it I'll name it array just to keep it super general. Okay, cool. And I'm not gonna do the public static here. If you might remember from like a week or two ago, we talked about public static, which is more suitable for programming in the large. Like when you have multiple files working together, you have to start doing the public static stuff. But since I'm working with one file, we don't need that. We don't need that public static here. Okay. Cool. Let me make sure this. Let me make sure this runs real quick. So I'm just gonna do a print statement here that says like in method. I'm just gonna make sure it prints in method. in method. Okay, cool. So I'm invoking the method correctly. Okay, yeah. So for folks on the recording, I recommend pausing the video and trying out this exercise here. All right. Let me continue here though. So yeah, this is really just copying the for loop that we did earlier. So there's a for loop where the number represents each position in the array. And to keep it super general, you can say the upper bound is the array.length. Array.length is a member variable once again. So this member variable. Right, this will make more sense what members are when we talk about object-oriented programming. It's one of the last topics in this course. Okay, and then let me just redo this print statement here. Let me go the number here and then colon space and then the string here. New line. Okay, so for the decimal, yeah, I'm gonna put the I, and for the string, access the array at I. Okay, let me test this. So Java, boom, and yeah, same exact behavior. Sword, pickaxe, null. Okay, cool. Looks good. Okay. Any people cool with this so far? Okay. I do want to point out some possible pitfalls. I'm not sure if you'll run into this. But one possible pitfall is not looping the element. Some folks might think you can print out an array like this right here. Let me just comment all of this out. Or I'm gonna delete it. I'll bring it back. Some folks might think that you can just print out like array here. Like, wouldn't it be convenient if we just call the print statement and then put the array in here and then have it do all the work for us? This works in some cases, but in this one, it prints out this over here. So this print statement is giving us some weird values. So if you're curious what this is, it's kind of like an identifier for the array. It's not really printing the elements in it. This is, if you really want to get into it, this square bracket is saying it's an array, and then this is this next part is saying the type, which is a string, and then this next part is the memory address. It's a virtual memory address, which is pretty much saying where in the computer is the array stored. Right. Well, it's stored at this address here. This is just a fancy number, right? So the number represents where the array is. So yeah, this is a possible pitfall. It works in some cases, but not for this plain array. Okay. Okay, cool. All right. Let me run this program again. Okay, cool. Any questions about this? Check the chat logs. Okay, people all good. Nice. Okay, let me point out one more pitfall though. This is a very common pitfall actually. This happens so many times. Out of bounds. Out of bounds. You've seen this with strings, by the way. Like, here, let me pull up a J shell here, just because I don't want to write a whole new program. Okay, so J shell. Say I had like a string here, right? We're not talking about arrays. Just plain strings. Let's say this is equal to hello. Or yeah, I'll just say hello. Okay, so we could access individual things here, like text 0. Right? Can I do this? Oh, whoops! I was thinking about C++. My bad. My bad. In Java, I think like text.char at. Yeah, text.char at. So so text. Let me just start over here. So text evaluates to hello. If I were to say text.character at 0, this gives me H. 1, this gives me that, and then all the way to 4, this gives me O, which is the last letter. But then if I put 5 here, I get a weird message. It's actually not weird at all. This is a totally normal error message. Index 5 out of bounds for length 5. So yeah, what's happening here is, if we were to talk about arrays, it's pretty much the same thing, right? Like here, say you had a array of 5 integers. Well, in memory, it's represented like this right here. We do start counting from 0. So if we were to access the length, right? The length here is 5, by the way. What this is out of bounds, right? You see, because the length minus 1 is the last one. All right. So this is a possible pitfall, especially when you're writing loops. Some folks might accidentally do like a less than equal here. Right, so all I did was put it in a less than equal here. This actually invokes an off by 1 error. Which we'll see right now. So we'll run it, and yeah, people see it. So we printed out everything here, and then the for loop gets to 9. Right, the for loop gets to 9 because that's the array length. But then it fails in the print statement. You can see it fails in the print statement right over. Wait, does it fail in a print statement? Let me. It should have said error message on line 3. Oh, it did. Here it is. Cool. Yeah, error message, error on line 3. So yeah, it failed. It failed right here because we tried accessing out of the bounds. All right. Okay, so yeah, this is very common. Okay. Cool. So the takeaway here is the last element position is represented by the length minus 1. All right, let's move on. Let's see. Thinking about moving into some class exercises. Yeah, you know what? Let's do a class exercise. Just want to make sure folks can apply this stuff. Okay, and for this case, I guess we could keep it in one file for now, just to keep things really simple. Let's keep it in one file. If you want to put it in multiple files, feel free to see the last recording. Right, the last recording we talk about how to use public static to put in multiple files. But for here, I'm just going to use one file. Whoops. All right, let's do a class exercise. I just want to make sure folks can write loops that goes through arrays here. Okay, so let me. Should I do it in this one over here? Nah, let's make it in a whole new file. Yeah, let's make a whole new file. I'll call this one like array statistics, because that's what we're doing here. So let's do some array statistics. Make a file. Okay, array stats.java. All right. The goal of this is just to see if we can write some methods to do some basic statistics. And for the sake of this exercise, let me hard code some arrays, some numeric arrays actually. Like let's say we were working with maybe maybe exam scores. We just finished the exam, so maybe we could pretend like that. Let me go ahead and declare an array. So here I'm going to declare an array of something called exam scores. Let me pull this up again. I'm gonna refer to this slide here. So let me go ahead and declare something called exam scores. So I'll double exam scores. All right. So this is saying make an array of doubles and name it exam scores. All right. We do need one more piece of it, which is initialize it to some block of memory. So that this to the right of the equal sign, when we say equals new double 10, this is assigning it a block of memory. So let me assign it a block of memory. In this case, it's going to be a new double. This is a command to allocate memory. So new double, and then let me just use like I'm going to use a small number. Let's see. Let's say like 6 here. Just keep it very small. Okay. Cool. Exam scores equals new double 6. You know what? Maybe I should use a different one so I don't have to initialize every one of them one at a time. Let me use a different style actually. You could use this style over here, which is useful if you already know the values, because you can just hard code them to the right of the equal sign. So let me use this style over here. All right, exam scores. Let me say like 5. No, let me put actual good numbers. 100, 95, and then let's say 98 again. And then let me put a low number somewhere here. Let me put like a 75 here, and then maybe another 100. Okay, let me make sure this runs real quick. Okay, cool. It compiles and runs. Great. And you know what? Let me make sure this array is initialized. I'm just gonna quickly do a for loop. By the way, I think you can do something called a range-based for loop. Instead of doing like int I is equal to 0 or something, there's another style of for loop you can do. Let me look it up. It's called like a range-based for loop in Java. It's in the reading somewhere, but let me just Google it instead. Range-based for loop. Basically, this range-based for loop, or for each loop, as some people would call it, it's a little safer because you won't really run into off by 1 errors. Okay, cool. We can just do this style over here. So let me go double score. This name doesn't matter. It's just representing a single element in the array, and then colon the container. The container is exam scores here. Okay, so all I'm doing is sanity checking. Looking at score. Let me make this a print f. Looking at score, some number here. No, some f, float. Okay, and then the float here is the score. Okay, let me just test this. Okay, you know what? I should probably round it off to 2 decimal places. 0.2f. Okay, great. It looks like our for loop is working well. So I know I kind of just snuck this loop in. This is for each loop. It's just another style. As you'll see in programming, there's like a million ways to do the same exact thing. But yeah, this is called a for each loop. It's really the same thing as hit this right here. You don't have to type this, by the way. I'm just gonna do it really fast so you see what it's doing. So this loop is the same as this loop here. I is less than exam scores dot length. make sure there's no off by one errors. Plus I, and then looking at score. Instead of score, this is going to be the element at I. All right, yeah. So both of these are the same. You can verify right here. See, so I just ran the program, and then the first for loop does this here, and then the second for loop does the same exact thing here. So yeah, good old for each loop. It's very, very safe. Because if you were to use this classic loop, it's really easy to do off by one errors. Like if you did like a equal sign here, right? This equal sign will give you an off by one error. Okay, anyways, our goal here is to do some statistics. This is, I'm gonna delete this here. This is just a sanity check. Let me delete this. Okay, so I hard coded an array here. For this exercise, let's spend like 10-15 minutes on this. It's pretty good one actually. It's a good takeaway. Let me see, where's my, here it is. Okay, let's do some small statistics like average, right? You've kind of done this already in your previous programming project, the temperature statistics. You might remember we did like average, minimum, maximum. This is very similar, but we're working with arrays instead. So imagine if we had some method here called like average. Right? Imagine we had a method called average, and it takes in a array of doubles. Okay, but in this case, we want this method to return some value. So it's a non-void value, meaning we can store it somewhere. Or actually, instead of storing it, let me print it instead. Let me just put in a print statement. Let me system.out.print printf. This is gonna be a little tricky to type because of the parentheses and stuff. So printf. I should probably make this a little easier to read. Let me printf average is some number here. 0.2f actually. 0.2f. Average is here. Let me make this a little easier to read. This way you don't get like. Okay, so say we were to invoke the method. Right, so this is invoking the method here, and say I store it into some value. Right, so double, I'll call it like double. I'll call it mean. All right, you can call it whatever you want. I was careful not to name it average because there's a chance it might clash with the name of the method. So I'm just gonna name it mean just in case. Okay, so then we put the mean here, and I'm gonna let folks do this as a class exercise. So if I were to compile this, it's not gonna compile, so it doesn't even run. The class exercise is to see if you can define this method here called average. All right, so here, let me help folks get started on this. Feel free to pause it right now, by the way. I don't want to have too many spoilers, and I know most people are watching it as a recording. But yeah, if you're watching this as a recording, now is the time to pause the video and try it out yourself. Instead of being spoiled to the solutions. Okay, so let me if you didn't pause the video, let me help you start off with this here. So we need to invent a method called average. But what is the return type? Right. Well, we can see the return type is returning a double, so it's double here, right? It's a non-void method, and the name of the method is average. Okay, and then we need the parameter. Right, the parameter describes the input. So the parameter here is just a double. It's just a double array, and you can name it whatever you want. I'll call it like numbers or something. Right? It doesn't matter what this name is. Okay, let me do a dummy return statement real quick, just to make sure it's working. So let me return 0.0. This is hard coded. It's just so we can see this print statement working. Okay. So Java array stats. Okay, average is 0. Perfect, perfect. So yeah, let's see if folks can do this. Let me put a 10-minute timer up real quick. All right, let's do a quick class exercise. All right, and then let me pause the recording here. For folks on the Zoom and in person, let me know if you're having trouble with anything. Okay, pause. All right, welcome back from intermission, folks. Okay, hopefully folks give that a try. Okay, cool. So this is very similar to our temperature statistics assignment. Basically, for this average, you just gotta find a way to sum up all of the numbers and then just divide it by the length, because that's the average. Now, so the numerator, we should probably set up the numerator. Numerator, you can represent it as like a sum, right? And then the denominator, you don't really need to get the denominator because it's just the length, right? You don't really have to count it up one at a time because the array already has a length variable. So I mean, if you wanted to, you could do something like count. This is the denominator. You could set it equal to numbers.length, which is the size of the array, length of the array, I mean. So yeah, you could do that. And then all you really need to do now is accumulate the sum, right? So we got to make the sum bigger and bigger. And one way you can do that is in a for loop. All right, so you could do a for loop here. I'm gonna do a for each loop, or yeah, a for each loop. So let me say that single element is a single num, and then colon, and then the container, which is numbers. All right, this is just a for each loop. And then what else? Oh, and then I need to accumulate the sum. Sum plus num. All right, cool. And then yeah, so this loop is accumulating the numerator, and all we need to do now is just return the average. All right, the average is the numerator divided by the denominator. Okay, let me go ahead and test this real quick. Let's see. I mean, as a sanity check, let's see. The average looks pretty high here. Right, there are 5 scores. That the average is probably, I don't know, gonna be like 90 something. I'm thinking it's 90 something. I'm not sure. You could verify in your calculator. But I'm gonna here Java array stats.java, and yeah, 93.6. This looks about right. Just to sanity check it, if I were to make some zeros here, like let me put in a couple of zeros. So there's a couple of zeros. This should drastically lower the average. I'm not sure what it's gonna be now. It's probably gonna be like 60 or something. Let me run it. There it is. Yeah, 59. Yeah. So yeah, just sanity checking this. Okay. Let me change these back to some high numbers. Okay, great. So that was the first one. I would recommend folks to try out these next ones over here. This is a really, these are likely to be on the future midterm. I mean, final exam. Any class exercise is likely to be on the exam. So if you were to get like this function method here, which is find the biggest number, I would recommend trying that out. I'm probably gonna let folks do that as lab time. The reading also covers this. But if you were to like have like a method called max and give it like the array, you should expect this method to return the biggest number. Meaning you could store it. Right? You could store it into a variable. I'll call it like a high score or something. Right, high score. So yeah, this is a class exercise you should try out. So if you were to print it, if you did the temperature statistics assignment, this should be a little easier. High score is a float, and then high score. Okay, let me set this up over here. I'm not gonna fully do the function. I'll just set it up for folks to do it on as like lab time or something. Okay, and I did collapse this method over here. Okay, so double max, and then this takes a parameter. The parameter is a array of doubles. You can call it whatever you want. And then I'm just gonna do a dummy return value. It's gonna return 0.0 again. Okay, this is just a temporary return value, just to see if it prints out 0. Okay, high score is 0. Cool, cool. Yeah, so to try this out at home, folks, I'll call it like a class exercise or a lab exercise, just so you can have a bit more time. Okay, and then if you want, you should probably try out the minimum as well. Right, the opposite of max is min. So you could imagine there's another method that does the same thing. I'm highly recommending this. This is kind of a prerequisite before next lecture, by the way. Next lecture, we're going to be doing some more complex array algorithms. And it's really going to rely on us to know how to do this class exercise. All right. Okay. So go ahead and try that at home. I want to back up a bit and introduce another thing. So today, our goal was to talk about arrays. We should probably talk about array lists now. It's pretty much the same thing. Both these are pretty much the same thing. It's just that array lists are arguably better. They're so in short, arrays are they're like primitive. That they don't have like a lot of things that can be done. But array lists are fancier. These are this is a fancy array, right? And it has a lot of access to methods that you'll see. All right, so let me rearrange a couple of these real quick. Oh, I need to fill this in later. I'm gonna to do this in just a bit. Let me just move a couple of these things around. Okay, let's put the array list over here. Okay, so yeah, let's go ahead and cover array lists now. This is once again, for a lot of folks might be ahead of the game already. I saw a lot of the previous submissions. Some people used array lists for their assignments. But that's totally fine. If you use array lists for the previous assignment, you're probably not going to get a lot out of this next piece of the lecture. But it's okay. It's totally fine. You can put this in the background. Okay, so let's cover array lists, and then next week we'll talk about algorithms. This is going to be applying everything. All right. Okay, so array lists are pretty much the same thing. It's a data structure, and it has access to a lot of things. So the main difference is well, the ancestor of an array list is an array. Right? Arrays are primitive. Array lists are fancier. That's pretty much it. Since array lists are fancier, it has a lot of features. One of the biggest features array lists have is the resizability. With arrays, I forgot to mention, with the earlier arrays, these primitive ones, the primitive ones where you declare like this, these are fixed size, meaning that when we allocated memory for 10 items here, it's always going to be 10. It's you can't really resize a primitive array. One of the only ways you can do it is by kind of creating another array of like double size and then copying everything over. So it is possible to resize it, but it's not really resizing. It's kind of creating another array. But with array lists, it has the ability to shrink and grow. All right, and it's got tons of other features too. So let me just click on this documentation and highlight just a couple of things we'll see. Okay, you can Google this, by the way. You can Google up like ArrayList Java, or take a look at the reading. So you can Google it here and look at the primary documentation. Primary documentation is a little hard to read, so the reading here might be a little friendlier. You can go to lists right here, part 3.2. This is array lists. Right, so they'll cover this as well. But I'm gonna refer to the primary documentation just to point out a few things we'll see. I highly recommend reading this, by the way. This reading over here. But as for the primary documentation, we're gonna see some methods here, like add. There's a method called add. What else? There's a method called get. We're gonna see this as well. They're pretty much opposites. One is writing to the thing, and then one is reading. Okay, and then there's some remove methods. We'll probably see this. Size, this is a method. We'll see this as well. So if you're wondering what I'm pointing out methods that arrays don't really have. We're here in ArrayList. This is a class. It's not primitive. It's very fancy, and it's pretty much most of these things, these methods, arrays can't really do unless you do them manually. All right, so let's introduce some syntax real quick. All right. So the biggest difference with an array list is it's resizable. So you don't really have to tell it how big to allocate. All right, so let me revisit this old example. It's hotbar.java. This is the first example we did in the beginning of class. All right, so recall that we had an array here. Okay, so let me just comment this. This is an array, or it's like a primitive array. I'm gonna put it in quotes here. It's a primitive array, meaning it's not really that fancy. All right, let me make sure this runs actually. Okay, it does run. Cool. Another way we can do this. Here, let me comment this over here. Let me make a array list here. So I'm just gonna comment it. So one way we can do that is with the syntax over here. It does look a little fancier, but basically it does start with the variable type, and the variable type here is just an array list. All right, this is included in the Java language. So array lists, and then we do have to tell it the type. Whoever invented the array list decided to use these brackets here, where the inside of it represents a type. So if I were to use a string here, this is pretty much like saying this right here. Right? This is a string array list. This is a string array. All right, and then now we need the name of the array list. So I'm gonna call it hotbar. Okay. Let me disable this line, actually. I'm gonna disable this line, this way I don't get a name collision, because I have two hotbars here. Let me disable this one. Okay, cool. So now we have a kind of like a reference. Now we need to like allocate it some memory. All right, so I'm gonna set it equal to a new array list. Okay, set it equal to a new array list of type string. Okay, and then this looks a little weird, but you do need these parentheses here. These open parentheses. You need them because it does something called construction. But basically, these empty parentheses says construct something. If you're, this will make more sense towards the end of the semester, but I'm pretty much talking about this right here, this constructor. So that's what the empty parentheses mean. Okay. Cool. So yeah, we just declared an array list, and it is size 0. So let me see what's happening here. So this is size 0, by the way. So if I were to do this over here, let me delete these over here, or let me comment it out. Should I delete it actually? I'm trying to make this easier to read. Here, let me delete this over here, and I'll comment this out. So let me make sure this compiles first. So Java hotbar. Okay, it compiles and runs. Okay, let me get this over here. So this is attempting to set the 0th element to like a sword. If I were to compile it and run it, oh, it does compile. Oh wait, I didn't save it. My bad. It shouldn't have compiled. So let me save this. Let me save this real quick. Control S, then. Okay, cool. So I just ran it, and I got a compile error here. Array lists are just like arrays, but the style was a little different. This is kind of like a raw access. It's kind of like a raw access that's really made for primitive arrays. All right, it's raw because these square brackets is kind of called like a raw access. With an array list, we kind of want to do things a little differently. I'm attempting to add an element to the 0th position, and with an array list, there are some methods that does that. Right, the array list has a different style. Here I'm trying to use a method called add. So there's a method called add, and then you give it some element. That element gets appended to the end of the list. Right, append means to put at to glue at the end. So we could use this over here. We could use this method hotbar.add. Right, so add, and then I'm going to give it the element. So the element here is what's it called? I want to give it sword. Alright, so this is resizing the array, by the way. This is adding and resizing the array list. So it's kind of doing two things at once. Okay, so let me go ahead and run this over here. Let me delete this primitive array. Okay. I probably should have left that plain array there. Oh well. Okay. Okay, cool. So now this compiles and runs. So we could go ahead and check it now. Let me go hotbar. Let me add one more thing, like a pickaxe. Okay, let me make sure this runs. Cool. It runs. Let me sanity check it by printing everything here. So I could print it. I have this method here. This method is a little different though. Like if I were to try to use this, it's probably going to error out because this method is made for arrays and not array lists. You see how this is saying I need a array list. So let me compile this, and yeah, we get a compile error. Basically, it's saying the method requires an array, but we gave it an array list. So the easiest way on fixing this is maybe, you could rewrite this method. Right? You could copy this method again and then just write it with a different parameter. So let me do that real quick here. Print array. Let me call it print array list actually. Print array list. And then in this case, I'm gonna give it the parameter array list. So the array list, you can just get this over here. So yeah, this is the type of the parameter, and you can name it anything. I'll name it like list. Okay. Cool. And then yeah, so same thing. Here we just need the for loop. You could do a classic for loop. But instead of the array.length, the array list uses something called a size here. It's just a different style. It's really the same thing. However, this is a method. It's not a variable. So we do need these two parentheses here. These two empty parentheses because we're using a method. All right, so list.size. Okay, and then now I need to do the plus I. And then let me go ahead and print it here. Okay, %s. And then let me get the I here, and then the string here, which is oh, and then when we're accessing things, we don't really use the raw access anymore. So so here I'm attempting to do like a raw access because of these square brackets, but I don't think this is gonna work. Let me test it. Let's see. Yeah, so the very first error here is pointing at this this raw access. Basically, with array lists, the style is you have to use like a accessor function, accessor method, and there's this method here called get. So the get is a little safer. It's pretty much wrapping the primitive raw access. So we could use get and then some number as the argument. Right? The number represents the position. So this would be a list.get I instead. Right, instead of this over here. Okay, let me go ahead and run this. So Java hotbar, and then I still did not compile. Oh, so this is the first error here. I meant to use print array list instead. I was passing it to the wrong method. Okay, now it should compile. There it is. It compiles, and it runs as well. So yeah, the difference here is we use an array list. This is like a resizable array. It's a little more convenient to use, in my opinion, because you don't really have to keep track of the size. Basically, as you add onto it, the size will get larger and larger. There's a lot of background work being done. And you can remove things, by the way. You can remove things like here. There's a function, method called remove, which is pretty much like a search method. Or you can use this over here. You can remove at a certain position, which classic arrays can't really do. So yeah, I highly recommend using array lists when you can. Really, in my opinion, the only reason to use a classic array is if you want to be very simple, like if you don't really need extra features. All right, but I think an array list is usually always better. Okay. All right. What else? You know what? Let me quickly rewrite this. I kind of feel bad for deleting some previous info. Okay, let me just copy this over again. I deleted some stuff. The array method. I'm just gonna put aside. I'm gonna put two mains here so you can kind of see. The first main we saw was using an array, a classic array. So I have two mains. I'm gonna use one of them though. So in the very beginning of class, we saw a classic array where the style is a little different. The style is over here. This is a classic primitive array. So this was like a, I think a string array hotbar is equal to new string array 9. I think this is what we did. New string array, yeah, and then yeah. So this is like the same as this over here. It's just a different style. And then adding 2 elements. This is a raw access here. So it's a little different. This is like saying this. It's kind of the same. The only difference is this array list is resizing, and this one is not resizing. And then equals to pickaxe. All right, and then we need the print array. So yeah, these two mains pretty much do the same thing, just slightly different. Okay, print array instead, and then hotbar. All right, yeah. So this was the old stuff. Let me comment it out, or actually, let me make sure it compiles. Where's my terminal? Okay, Java hotbar. Okay, cool. It compiles. So this was in the beginning of class where we printed a plain array, and then now we converted to array lists, which is right over here. This brand new main. All right, let me go ahead and run this. Make sure it does the same thing. Yeah, it's pretty much doing the same thing. It's just ignoring the null values. All right. Okay. Cool. Hopefully that makes sense. If that didn't, maybe this reading might clear it up a bit more. Basically in 3.2 and 3.3, these two things are kind of talking about the differences between them. All right. Okay. Cool. Yeah. So there's many ways we can do an array list. Here, these are just showcasing a few methods. They come from the documentation. So all I really did was use this primary documentation here and kind of show some concrete examples on how to use it. Like, let me see over here. I'll have to put this side by side. Like we saw this. We saw this before. This is constructor. We use this names.add. This comes from the primary documentation. This .add. So I'm using this right here. And then there's the remove method. We haven't really talked about this, but you could try it out yourself. There's a bunch of methods that you can use. You see there's like 100 of them. Or not 100. But, there's quite a lot. Okay. Okay, I think that's it for today, folks. So yeah, it looks like we're gonna end like 15 minutes early as usual. On the next week, we're gonna do some more more complex algorithms. But basically, this whole time we've been doing like one-dimensional iteration. Like this hotbar was one-dimensional because yeah, there's only one dimension. But in the future, we're probably gonna see more. Let me pull up my slides from earlier. I'm planning on releasing like some sort of tic-tac-toe assignment. Like we're gonna talk about two-dimensional data structures later, by the way. So this is gonna be stuff like. Let me pull up some. Give me 1 second. Loops. Here it is. I'm pulling up some old slides. Let's see. Oh, next week we'll talk about nested loops again. Right. So a few weeks ago we gave a sneak peek. We gave a sneak peek into multi-dimensional iteration. We talked about like a we talked about a search algorithm where if you were to search things like how many times are there targets in the data, right? Like pretty much I'm saying how many times does Lin and Uriel appear in here. Well, this requires a multi-dimensional iteration. A multi-dimensional, there's other words for it, but I'm calling it multi-dimensional because one way you can do it is by iterating through here, this large data, and comparing it with each of the targets. So you can imagine David gets compared to Lin, and these are not equal. So compare it to the next one, right over here. Right. So David is not equal to Uriel, so nothing happens. And then we can iterate to the next one. All right. We can iterate to the next one. We can look at Uriel and say, hey, does Uriel match his target? No. Does Uriel match this target here? Yes, it does. So maybe something happens, like increase a number. And then look at Alice. Does Alice meet this? Nope. Does Alice meet this? Nope. Yeah. So this is what I mean by multi-dimensional. It's kind of like we're iterating. Imagine this as the outer dimension. Right, this large data is the outer dimension, and then for each of these elements, we're going to compare it to an inner dimension over here. So it's kind of hard to see what I mean by inner and outer, but it would make more sense in a future assignment. I'm planning on delivering some sort of tic-tac-toe where you'd have to represent a data structure, like a two-dimensional data structure, which we'll talk about later. We'll talk about this stuff later next week. All right, so before next week, I highly recommend practicing the exercises we recommended today. In particular, you should at least know how to do single dimension iteration. Like we did do this class exercise on getting the average from a single dimension array. And for the lab activities, you should probably try doing this max and min again. This is a prerequisite for next week's stuff. Right. Let's see. Okay, yeah, that's it for today, folks. We're gonna end like 15 minutes early. I'll publish another assignment soon, which will be due like next week or something. Okay, thank you all for being here and have a good day. Bye.